Good day. My name is Royalie, and today I will be sharing my reflection on some fascinating and essential topics in computer engineering, specifically around chip manufacturing, CPU production, and future trends in our field. As computer engineering students, we are often focused on learning the theories and coding skills needed to build technology. But when we dive deeper into how our technology is actually made, like the microchips and processors inside every device we use, it opens up a new level of appreciation for the engineering challenges and advancement that shape our world. In this reflection, I will take you through some of the complexities of chip manufacturing, the intricate process of photolithography, and how CPUs are made from silicon into powerful processors. Finally, I will touch on some emerging trends that are reshaping computer engineering, highlighting the exciting possibilities ahead. Let's get started. Reflecting on the complexity of chip manufacturing and the future of computer engineering. In a world where devices keep getting faster, smaller, and more powerful, it is easy to overlook the engineering feats behind these advancements. Chip manufacturing, especially for CPUs, requires processes that push limits of science and technology. For computer engineering students, understanding these fundamentals provides insight into why even minor improvements in chips involve groundbreaking work and substantial investment. For example, think of a smartphone which might be thinner than a book but contains billions of transistors, each acting like a tiny switch. Manufacturing these at such a small scale involves technologies and precision that almost seem like science fiction. Additionally, chips are more than just parts inside of our devices. They are the brain of every digital product, and understanding their complexity gives us insight into the entire tech ecosystem. Chip manufacturing connects to every field in engineering, from material science to nanotechnology and even physics. For me, exploring these processes is not only about understanding the present, but about seeing where I could contribute as a future engineer in this evolving industry. Complexity of chip manufacturing. The process of making chips is one of the most complex engineering undertakings. Chips are made from silicon, a common element, but turning silicon into something as sophisticated as a microprocessor involves extreme precision and cleanliness to avoid contamination. For example, imagine a factory room so clean that the air has fewer particles than anywhere on Earth. Technicians in full protective suits operate machines worth millions of dollars to avoid any contamination that might compromise a chip's performance. This is the level of precision necessary because these chips will ultimately manage billions of calculations per second. Another topic is photolithography, the heart of chip manufacturing. It is one of the core techniques used in chip manufacturing to circuit patterns on two silicon wafers. This process uses UV light, mask, and chemicals to create intricate patterns. The finer the patterns, the more transistors can fit on a chip, increasing its processing power and efficiency. This method has allowed chip manufacturers to achieve massive reductions in chip size while increasing processing capabilities. Let's move to our next topic, how CPUs are made. CPU production involves several stages, each building on the previous one to turn silicon into a functioning processor. After the silicon wafer is prepared, it undergoes processes like doping, layering, and etching to build the processor's circuit pathways. These stages transform raw materials into an incredibly powerful computing unit capable of performing billions of operations per second. Additional details about the CPU production process. It doesn't stop at silicon wafer formation. After layering circuits through photolithography, CPUs go through a process called doping, where impurities are added to modify silicon's conductivity. Following this, additional steps like metal interconnects are added to allow different parts. For example, imagine baking a multi-layer cake where each layer needs to be precise down to the millimeter. CPU manufacturing is even more precise. Layers are added to the silicon, forming circuits that will become the logic gates and pathways of a CPU. Each step from doping to final inspections ensures the CPU functions correctly at incredibly high speed. For me, this deeper understanding reinforces the importance of quality control and precision in engineering. It is a reminder that each CPU, no matter how advanced, is only as good as the precision with which it's manufactured. So, last but not the least of our topic is future trends in computer engineering. Computer engineering is a field that evolves rapidly. Innovations in artificial intelligence, or AI, machine learning, quantum computing, and new semiconductor materials are reshaping what is possible in computing. This technology do not just push forward device capabilities, but also open new career paths for engineers. In addition to quantum computing, AI-driven chip design is another emerging field. With AI, we are now able to analyze vast amounts of data and optimize chip designs for specific applications, making chips even faster and more efficient. So, this advancement points to a future where the boundaries between traditional and next generation computing blur. Learning about these technologies gives us as a computer engineering student, a roadmap to understand where our skills can be applied and what new tools we may need to master. For example, quantum computing is one of the most exciting fields because, unlike classical computers, it uses quantum bits or qubits that can process complex problems in seconds rather than years. For computer engineering students, I learning about these advances highlights how the field isn't static. There is always something new to learn that could impact the entire tech industry. Therefore, I conclude that for us as students, this level of precision highlights the importance of attention to detail in engineering. It reminds me that engineering isn't just about big ideas. It is also about executing the smallest task with perfection. Because in tech, even minor errors can lead to significant setbacks. In reflecting on these topics, I realized that every chip, every processor, and every innovation we see in technology reflects countless hours of research, precision, and dedication. For me, as a computer engineering student, it is a reminder of the impact we can have through our work and the responsibility we carry to keep pushing the boundaries of what is possible. So, next time you see a smartphone or a laptop, consider the vast network of people and processes that work together to create each component. By understanding the technical details behind these devices, we gain both respect for the craft and inspiration to keep learning. Thank you for listening and watching. Have a great day ahead.